Hello everyone and welcome to a new series. In this series I'll be going over some experiments in math and physics that I do using Unity. So the first experiment, this is not really a tutorial, it's just some things I find along the way that I want to share, which I find interesting. So what this is basically, let's reset this. So as you guys can see, it's just a ball and a slope. So we want to input an angle for the slope, let's say 30. So if I do 30 and submit the angle, as you guys can see, it's right above the slope. So how do I want to show you guys how I find the height or where this is in the y-axis depending on the angle you input. Let's say we inputted 30 this time. So let's get right into it. It's actually very simple mathematics, so I'll show you guys the code and how it looks like in the actual math. Alright, as you guys can see, let's call this angle A and just keep that 40. And why I'm using 40 is because I measured this length and it was 40. Alright, so I'll be using that, but depends on what yours is. So you can find out using the scale on your game object. So let's say I input the angle of 30. Well, I'll be using 30 in this, but you can input any angle, of course. So yeah, we have the angle of 30 degrees, and what we want to find is where this ball would be in the y-axis. As you guys see, not x-axis, we don't want that, or the z-axis, which is coming from in front or back. We want to find where it would be depending on the angle we input for the slope. Let's say, as you guys can see, this white line over here, that is the slope. We want to find out. Basically, as you guys can see, I want to put the ball about here from the slope so it can roll down pretty smoothly. If I don't do these calculations, I have to estimate it, and a good way to do that is just make it drop, which would just give it bounce, which we really don't want. So it's actually a very, very easy way of calculating it. So let me show you. As you guys can see over here. So this is, let me open a new one. So basically there's a triangle. Let's say I can draw a triangle to my best. Okay, so let's say the angle is 30 in here, 30 degrees. And 40, it doesn't really need a unit technically. So yeah, 40. Okay, but what do we want to find? Well, we want to find this one. Let me draw a question mark. Okay, it's actually very simple. If you guys know the trigonometry rules, I'll be going briefly over what these are. Okay, so to find out this, what do we need? So basically, let's go back to the diagram. We don't need the sine. We don't need the cosine because we don't need this length, or the sine, or the cotangent even. We need the tangent because we want to find out how tall it would be. So what we need is to use this one. And I'll talk about what O and A mean. So H is hypotenuse. This is the hypotenuse. A is adjacent. So adjacent meaning adjacent, the adjacent length to the angle. So right now, adjacent to the angle is 40. So that's our adjacent. So let's bring that back and put that A. Now what is O? Well, O is actually the opposite of the angle. So this is O. So that's why I wrote THOA. So we need to use this one for now. So I'll just teach you guys how to do that. So we have the angle. So the normal, it's called the formula, is sine of theta, which is just the angle, equals to opposite over adjacent. That's why it's THOA. Okay, so which one of these values do we have? Well, we actually need to find the opposite, but we do have the angle and we have the adjacent length. So let's put that in the formula and find it out. So tangent of 30, which is the angle we have over here, degrees, sorry, okay, equals to opposite over adjacent, which is 40. So this is pretty simple, finding O. So what you do is just make O equals to tangent of 30 multiplied by 40. Then you'll be able to find this length. So that's it for here. But let's go do the code of it. And as you guys can see over here, we're in Visual Studio, and in my code, we don't really need this part. So yeah, okay. This is the line we're going to be focusing on. The rest is just normal Unity stuff to get the stuff from the input field. So this is the line. We want to set the ball position of it to a new vector 3, which is, of course, a vector 3 because it's a 3D space. 35F, don't worry about it. We don't need that. Neither -1 because that's the X and Z axis. But what we want to find is the Y axis. So this is the line of code we kind of should worry about. Okay, not really worry about, actually we don't need this part as well. So yeah, okay. So as you guys can see over here, math f. Oh, actually, the thing I removed was my offset that I needed. Okay, so yeah, math f is basically a function or a library inside C# itself. So you can use math f dot tan because we want to find the tangent, and we want to find the current angle. So the current angle is basically just the angle itself. So in this case, it was 30 degrees. So yeah, let's go back to the code. So I'll explain why we need to divide it by 180 and times it by pi. But for now, I'll just tell you guys. And why do we multiply for 40? Well, because we multiply by 40 over here. And 40, again, it was my length of the game object that I wanted to find, or I found already. So yeah, that's that. And then minus 10 is just the offset that I need to put because it's kind of wonky a bit. So yeah, that's basically that. So let me tell you guys. Okay, well, actually, so whenever an angle is input in Unity, basically, it's actually considered as a radian. Okay, and a radian is another form of measuring an angle, but we actually want it to be in degrees because in order for this to work more simple. Okay, so all we do, the formula is basically let's go back to our place and let's open a new one. The formula is theta. Let's say theta, I'll call it theta because it's the angle. I didn't draw it well. Theta over 180, this is just the formula of making radians into degrees, times pi. Okay, so what we do that, you just feed it into this formula, to divide by 180 times math.pi, which will convert this current angle into degrees, and then multiply by 40, and then of course the offset. So now, as you guys can see, as I ran it before, once you input the angle of 30, we'll see what happens. So let's input the angle of 30, submit, and as you guys can see, it's the offset of it, which makes it basically above it. You can change the offset, of course, depending on any angle. Just find a good offset that you think is good for any slope, actually. And then now we can release the ball, and it would go on, so forth. So yeah, I hope this helped actually, because it's a very easy topic to understand if you guys know basic trigonometry. If you guys don't know, it's alright. Now it's kind of more clear, but we don't use these two because we don't need to find the cosine or the sine. So as you guys can see, the cosine is this length, which we don't need, or the sine. We want to find the tangent to see where the ball should be at the end of basically whenever we input an angle. So yeah, thank you guys for watching. And this was one of my experiments that I've been working on, and I ran into a few issues along the way, and this was one of them, but I figured out it was much more easier with mathematics. So yeah, thank you for watching, and bye bye.